I'm Chuck Higgins, and I'll be talking to you tonight about the Cassini mission to Saturn. And we've got a full slate. I'll give you the schedule at the end of the talk later. But I always start off with just a brief history. We started doing these. Dr. Eric Klumpa started these in, I think, about 1999. And we have been doing them 4 times a semester, I know, since probably 2002 or 3 or something like that. So we've been doing this quite a long time. We certainly enjoy it. I can't top the eclipse. I just can't, all right? There's just no way that we that we can do any better than that. That was as good as we're probably ever going to get, but we'll try. We're gonna try. So if you got a handout, if you didn't get a handout, let me know. This is just the sky map for February, as you know, and it's kind of fun to see what's visible, what's out there. Unfortunately, Saturn is not out there, so we have to wait a little bit to see Saturn, or you have to get up early in the morning to see it. But there's the sky tonight. Dr. Klumpa is outside, chilled, waiting for us. So I'll talk 45 minutes, I think, and then we'll send you outside, look through the telescopes for as long as you can stand it. All right? So what is the grand finale? What is Cassini's grand finale? Well, let me go back and just give you a brief overview of Cassini in general, okay? So this is a couple of minutes, but it's nice. Pretty spectacular. Thank you. Good night. Hope you enjoyed it. That's all I have to say. No, I hope that's whets your appetite just a little bit. Cassini was, of course, the grand mission, NASA mission, and European Space Agency, ESA mission to Saturn. And this 20-year mission was arguably one of the greatest NASA spacecraft in history, with the amount of science, the ability, the success, the incredible ending, which I'm going to talk about here, to it is really, it's hard to beat. Here's just an overview of many solar system objects to give you a reference to the size of Saturn. How many of you say Saturn is your favorite planet? You got a few out there? I would say that, but I'm a Jupiter guy, so I can't. I would lose my job if I did that. I still remember the time, the place where I first saw Saturn in a telescope. It's just one of those things, if you get a chance to see it in a telescope, it's that good. And I'm sorry we can't show you tonight, but if you come back in the fall, it'll be good. So some of you came in a little bit late. We have some star maps here. Did you get one? Okay, great. And so Saturn is very, very large, right? It's a gas giant, roughly 10 times the size of the Earth. That's just the planet itself. When you include the rings, you see it's much, much bigger than Jupiter. So it's just really amazing to see in the night sky, in a telescope. It's an incredibly dynamic system with the various moons and the amazing rings, and the dynamics of the whole system is quite incredible. So just to give you a sense of where it is, so this is a solar system on top from today. So here you see Earth, and if you can imagine Earth turning there, and as the Earth turns and the morning comes around, the sun comes up, and there's Saturn, Jupiter, Mars in the morning sky. The night sky, of course, is over here. So if we simulated what it would appear to be in the morning sky, if you wanted to get up at 6 or so in the morning, that's looking east, southeast. There's Saturn, Mars, Jupiter before sunrise. So that's where it is at the moment, and that's an Earth-based view, but nearly all the other images I'm going to show you tonight are from Cassini or maybe a few from Hubble. And where are we here? So the Cassini spacecraft is it was one of these really expensive spacecraft. It's I forget the NASA terminology. What they call these things? An Explorer class. Here's an Explorer class. Anyway, it's the Galileo mission to Jupiter, and the Juno mission that's at Jupiter right now, the Voyager missions. These are the big guys in terms of expense and teamwork and duration of mission. It's a lot of money. So when they go, it takes a long time to get there. It was a 7-year flight to get there. And then they extended it twice, and really a third time, if you will, if you want to include this grand finale. So once it's there and it's working well, let's keep it going. So they kept it going for 20 years. And there were 12 instruments on board. So you've got cameras and infrared cameras and ultraviolet light cameras and spectrometers, radio equipment, gravitational experiments, a big magnetometer boom to measure magnetic fields, all the particle detectors to detect what kind of particles they're bumping into. And all this is packaged on an object that's size of a large bus or something, or a charter bus. So there you see it in construction before launch in '97. So if you are so inclined, let's see if I can find them here. If you go to the NASA website, you can print these off, but I printed them off on some cardstock paper. You can build your own model. And if you would like one, I have 4 or 5 here. I would ask the young ones first if they would like a model, and I'll give it to you. So I apologize, but this is the simple model. and there's 3 pages of it. You want one? Here you go.
Thank you.
You're welcome. It may take a little while to build. Anybody else? I've got 3 more copies here. Here you go. And that's on cardstock. And I've got 4 or 5 more that are on high quality paper. You want one? Sure. High quality paper, but just not cardstock paper. So there's a few more. Anybody else interested in building one of these? I have not built one. I can only imagine this is probably a 3-hour adventure here, but maybe not that much. But anyway, it looks like fun. The more complicated model is about 12 pages of stuff, and you need toothpicks and other things to make a more accurate model. But this one, believe it or not, is the simple one. There is also, if you're into 3D printing, you can go and find a 3D print file and print your own spacecraft if you like it. So anyway, hopefully that might be fun for some of you. All right, so this is how we got there. So a '97 launch, 2 Venus flybys, and then an Earth flyby, and then some orbit corrections, and that kicks you out to Jupiter, and then you slingshot from Jupiter out to Saturn. And as I said, it's launched in '97. It got there in 2004, so roughly a 7-year flight to get there, and then it was orbiting Saturn until last year. So the mission began even in flight, and it took a lot of data at Jupiter, which I looked at some of the radio data when it flew by Jupiter because I was interested in those data. But that's the way you do it. To try to save some fuel, you use the other planets to help you cheat a little bit, use less fuel, and then use some gravity assist to get out there. Let me move this out of the way. I'm going to bump into it eventually. And then once it got there, this is what it did. So it looks a little bit spaghetti-like, but almost 300 orbits around Saturn over the go next door. Okay, over the about 13-year orbit mission. And the color coding there is for the primary mission and some of the extended missions. Of course, some of the key questions when you get there is you're up close. You're able to, in a way, touch Saturn. You can directly sample some of the material. And you're in the magnetic field, so you can study it in situ, we say. You're flying right by the moons. You have a probe, the Higgins probe, which was released off the spacecraft to go and visit Titan, the large moon Titan. And you've got cameras to take pictures of the atmosphere. You can take movies. You want to look at the moons up close, look at the charged particles, and of course the ring system. And that was a lot of goals, but those are the key things that they wanted to look at. And just to give you a sense of scale here of the Saturnian system, so you've got the 10 diameter Earth planet, and then you've got these rings that extend out hundreds of thousands of kilometers from the planet, and then you've got now up to 62 moons around Saturn. And you've got some extended rings. So there's very faint rings you see near this moon Enceladus and others. So lots to look at here, and so it did. I'm just going to highlight a few of the key discoveries. So studied the radio emissions. It found these incredible winds and atmospheric patterns at the North Pole. I'll show you. It found that there was the probe that landed on Titan found lakes, liquid ethane, methane, hydrocarbon lakes. So that's the only solar system object that we know of with large lakes other than Earth. The moon Enceladus was really the unexpected gem of the moon missions, the moon flybys and studies. So they found that this moon was basically volcanic, spewing a lot of geysers out, and they flew through them, directly sampled the material, and found that it was water ice. So that is now a key target for the study of life elsewhere. It used to be the favorite target was Jupiter's moon Europa, which is a ice-covered moon with, we think, we're pretty confident, a liquid subsurface. Well, now we have Enceladus, which seems to be even more active. It's incredible that this activity exists in these cold worlds. So that was an incredible find. It discovered, I think, 6 new moons. It found lightning on Saturn. And it's this image, this thing called the hexagon, and this jet stream in the North Pole. Whoops, sorry, go back. It found new ring features. I'll highlight some of those in some of the images. Charged particles, aurora. It sampled or made some very incredible images of the aurora that happen in the northern and southern hemisphere. So more discoveries about Enceladus, and then another moon, Iapetus. There were some unanswered questions about why this moon had some dark and light features on it. So they were able to understand where this dark material came from. Another moon, Phoebe. So a lot of interaction here. So what is the grand finale? Well, it was essentially the end of the mission. So after the primary mission, which I think was about 4 years, they extended it for another 2 years in something they called the Equinox mission, because they wanted to see what the atmosphere and what the planet looked like during its spring, when the sun crossed the equator of Saturn. And then after that, they extended, well, let's keep going. Let's extend it to a solstice. And so the next part of the mission, the next phase, was a solstice mission. And that was 3 or 4 years, because Saturn's orbit period is about 30 years. So each season on Saturn is roughly 7.5 years. And so from one season to the next, so we had a whole season, essentially, or the beginning of one season to the next. And then the final mission, the grand finale. So here's another little 2-minute movie showing you some highlights of what this grand finale is. Let me just play this and I'll talk about it.
A lone explorer on a mission to reveal the grandeur of Saturn, its rings and moons. After 20 years in space, NASA's Cassini spacecraft is running out of fuel. And so, to protect moons of Saturn that could have conditions suitable for life, a spectacular end has been planned for this long-lived traveler from Earth. In 2004, following a 7-year journey through the solar system, Cassini arrived at Saturn.
SOI burn attitude or pointing position, light up the rockets.
The spacecraft carried a passenger, the European Higgins probe, the first human-made object to land on a world in the distant outer solar system. For over a decade, Cassini has shared the wonders of Saturn and its family of icy moons, taking us to astounding worlds where methane rivers run to a methane sea, where jets of ice and gas are blasting material into space from a liquid water ocean that might harbor the ingredients for life. And Saturn, a giant world ruled by raging storms and delicate harmonies of gravity. Now, Cassini has one last daring assignment. Cassini's grand finale is a brand new adventure. 22 dives through the space between Saturn and its rings. As it repeatedly braves this unexplored region, Cassini seeks new insights about the origins of the rings and the nature of the planet's interior, closer to Saturn than ever before. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends, as Cassini becomes part of the planet itself.
So I don't, or did not, work on this mission. These things start sometimes 15, 20 years before launch. And the team develops the spacecraft, and then they launch it, and then in 7 years, they wait till it gets there, and then it's a 20-year mission after that. So you can sort of see or hear the drama of a spacecraft that ends. Like, I'm sure, I mean, you've probably seen the videos of the scientists in the control room and hugging, crying, whatever. It's a big deal when a mission ends. So they are incredibly moved, those that have worked on these things for so long, have dedicated their life to it. So it is sort of dramatic in that sense. So why did they do this? Why this finale? Well, the spacecraft carries germs, essentially. They do disinfect the spacecraft before they launch it, but we don't know if it carried something with it. And the moons are extremely delicate, and we don't know whether there's life on these moons or not. So we don't want to contaminate these moons. So the best way is to burn up the spacecraft. So it won't, you don't just turn it off and just let it willy-nilly fly around out there, because it might end up doing something you didn't expect, and it might crash into one of these really interesting moons, and then we don't know if we can trust data if we discover something there. Yeah, question?
When you say germs, do you mean like it can carry diseases?
No, just human bugs, right? Anything, any microorganisms that are on the spacecraft. You've seen the images where in the construction rooms, and they're all clean rooms, and everybody's gloved and has the suits on. That's one way to try to protect the environment, essentially, and that includes the space environment. And so to avoid that, they burn it up in the atmosphere of, in this case, of Saturn. So the mission, and you know, the video shows you the incredible kind of the accuracy that are needed. And so on these big orbits, they swing by some of the moons, and that's how they get close-ups of the moons. And there you see Titan's orbit there in green. So in April, what they did is they flew by close enough to Titan to alter the trajectory of the spacecraft. So it was in a safe orbit around Saturn, but now you've nudged it, and so it's got, I can't remember, there's a couple of dozen orbits until the last orbit takes it into the atmosphere. And part of what they do as well is the mission is basically over. And so we're running out of fuel. Let's do something interesting that we wouldn't do otherwise. Let's take some risks with the spacecraft. Let's fly it inside the ring system, in between the rings and the planet. And that's very dangerous, well, because there's ring particles, but you also have a high radiation environment near there. So radiation belts, like Earth has. So you fly the spacecraft through those radiation belts, you don't know what it's going to do to your electronics. It could fry it. They don't know. But okay, so let's take some risks, and let's go very close to Saturn and get, so the final orbit's there in blue after the nudge by Titan, and you get really close into Saturn for a couple of dozen orbits, and then the last one plunges into the atmosphere. And of course, that burns up the spacecraft. If there happens to be any microbes that attach themselves and were on the spacecraft, presumably they wouldn't survive this burn-up entry. So that's the justification, the sort of the scientific, biological justification of let's trash the spacecraft and protect everything else around there, because we know we're going back and we want a pristine environment as possible. So that's the reason for doing this grand finale. So let me just show you some incredible photos, and many of these are multiple images, multiple wavelength photos, so they color code them. And here you see an infrared color enhanced, so the blue up in the right hand corner is the rings, off in the distance. This is the northern pole of Saturn. And there was this fantastic storm system, or I should say atmospheric system, where there's a cyclonic storm at the very center, you see in red, and then around the outside there's this hexagonal shaped jet stream, essentially. No one knows why that does that. It's quite fascinating. That, I mean, the central storm makes sense, but this hexagonal set of jet stream kind of winds, no one understands why that happens. So that was a really amazing discovery. And of course, we don't get a good view of the North and the South Pole from Earth, or even spacecraft in Earth orbit. So you fly over it, that's where you get the great pictures. So here is Enceladus. Direct images of these geysers. So it's volcanic. It's active. This moon, frozen little moon, is active. And there are lots of these little moons out there in the solar system. Many around Jupiter, many around Saturn. And you may have heard recently that when the New Horizons spacecraft flew by Pluto, both Pluto and its moon are active. They are getting energy, maintaining sort of an active crust, if you will. And that's incredible. That tells us that there is the surfaces of some of these moons are quite young. And so that means the ice or whatever is continually being resurfaced on there. So where does this energy come from? Mostly it's gravitational. It's getting gravitational energy from its primary planet. But that's an amazing occurrence to keep that energy over basically billions of years. So the geysers were an incredible discovery. And there's just a few more images. You see the surface of Enceladus. It's got craters on it, just like our own moon, but half of it has got basically what looks like ice flows. So at some point, this part of this is melted, right? This is water ice. This is not dry ice or methane or ice or anything like that. This is water. Water is very, very prevalent in our solar system. And some of that material that gets spewed out then makes a large ring, ice and dust particles. Here's just a view, a few of some of the other small moons. So lots of activity on these moons. You see these stripes. You see, of course, large craters, these valleys. Here's the moon Iapetus, where it's very dark surface, and then a very light snowy colored surface right next to it. So why is that? Well, as you saw before, that's due to another moon's dust, dark dust being spewed out and then kind of coating the ice, covering up the ice of Iapetus. So it's just incredible the number of worlds that are there. And here's, of course, the largest moon. Here's Titan. We knew it had an atmosphere, and we knew the atmosphere was made of hydrocarbons. So carbon, hydrogen. That's interesting. That's kind of the basis of life. Let's check it out. Let's look into it. And so this is a picture after the discovery, but there you see glint. This is infrared sunlight glinting off of liquid on the surface of this moon. Amazing. Here is the probe which landed, parachuted down through the atmosphere. So it's a very thick atmosphere. And so they designed a parachute to let it fall and land on the surface. And it took some pictures as it went down. And so there you see this crust, and then here's some liquid. And this liquid fills some of these valleys. Very Earth-like, isn't it? If you were taking a satellite view of Earth, that looks very much like a coastline or something. That is the surface of Titan. There is a spacecraft sitting on the surface of Titan. That's mind-blowing. That we sent something out 30 AU away. Sorry, 30. Where am I getting 30? 10 AU away. 10 times the Earth-Sun distance. And detached a daughter spacecraft off of the main, the mothership, and that spacecraft flew in and parachuted down, landed on this cold, icy world, and found that it was covered with lakes. And these little rocks are icy rocks on the surface of Titan. It's just mind-blowing that that image is real from a camera on that surface of that moon. And the clouds are so thick, optically, you can't see the surface. It's that smog, if you will, it blocks the visible light, so you've got to use infrared or radar or something to see the surface. But this is actually from the surface of Titan. It's incredible. Of course, the favorite viewing for most people is the rings. Just an incredible system of rock and ice, water ice. So they're very reflective of sunlight. And that's why we see them so easily in telescopes. So these rings start in diameter, and so radial distance, they're several hundreds of thousands of kilometers. Yeah, from the inner ring to the outer parts. And the thickness of these rings are less than 1,000 kilometers. So that's incredible. That's the sculpture of gravity and long amounts of time that these rings are in this plane. And there's moons. As you can see, there's a moon, Pandora, over on the other side there. Moons that help sculpt these things as well. So, I mean, they're essentially razor thin. The scale, ratio scale, if you had a piece of paper, I can't remember, the piece of paper has to be, 10 feet in diameter or something like that to give you the same scale of thickness to breadth. So that's how thin these rings are to how large they are. It's an amazing thing what gravity will do. So this is a Hubble Space Telescope, so Earth orbiter, looking at Saturn, and you see the rings from a unique point of view in the ring plane. They essentially disappear. They're that thin. So that's neat. That's a cool view, and you can see lots of little moons and the shadow of the moons on the planet. This is a neat picture. They did this at least twice, where Now this is Cassini, and kind of false color here, but Cassini behind Saturn, looking, so basically in eclipse, looking back towards the sun. Can you see Earth? Can you see Earth and Moon? I mean, you get up really close, there's a tiny, tiny, tiny little dot at the very end of that little white line. That is the Earth and the Moon system from Saturn. Makes you feel big now, doesn't it? Isn't that amazing? It's just, so they enhance the color a little bit so they can see more of the ring system there, but Earth, Moon, Mars, Venus pop out in the distance there. It's really quite extraordinary. So here is one of these fancy interactions of the tiny little moons in the rings. So essentially, these moons, we call them shepherd moons. They keep the ring particles, the tiny ring particles, which are really dust-sized particles, all the way up to, I don't know, home-sized boulders of rock ice, all in orbit, separately orbiting Saturn. Right? They're not tied together. This is all these particles are on their own orbits, but they're kept nice and tidy by these shepherd moons. So in this case, the moon Pan is in creates a gap, a gravitational gap between the rings, and keeps the outer rings from coming inward and keeps the inner rings from moving outward. So shepherd moons is a very apt name for these things. It's really quite incredible. And then you can see the amount of detail. I think I got another image here. Let's see. Yeah, so there's some detail of some of the rings. It's just amazing, the sculpture that you see. And if you look at the shadow of the rings on the atmosphere of Saturn, you could see how fine some of those rings really are. Let me go backwards here. I skipped over one. So there again is the ring shadows and an amazing storm in the atmosphere of Saturn that we think lasted at least, that has lasted, we think 30 years. So this is an image back in 2010, 2011. So Saturn is much more, sorry, there we go, the atmosphere of Saturn is a little bit different than that of Jupiter. Now, it's mostly hydrogen and helium, like all the outer planets. The moons are mostly rock and ice, water ice. But Saturn has a haze-ish layer in the upper atmosphere that makes it hard to see any detail. In Jupiter, you see all the detail in the atmosphere, all these storms and belts and things. Saturn is not as much, but in the infrared, so this is some infrared imaging, you kind of see through that haze, and you can see a lot of detail in the atmosphere. There's a lot of storms, bands of high winds, and cyclonic and anticyclonic activity in the atmosphere. And who knows what caused this storm? But it's just an amazing dynamic, because this is a gas held together by gravity. We don't really know deep down in the interior what it looks like, but certainly there's some solids, some rock, ice under really high pressure. But the atmosphere acts like a fluid, right? Acts like a liquid. And so you get a lot of dynamic motion going on because it's a big ball rotating, heat coming out from the interior, giving the atmosphere energy, sunlight hitting the atmosphere, giving it energy. So there's chemistry and a lot of dynamic activity going on. So one of the outer rings there, the F ring, is very dynamic. It's being influenced by this moon Pandora. So you see these little waves, those little kinks in the ring. All gravity doing this. Really, really quite amazing. So there's some close-ups of the rings. You can see lots and lots and lots of little individual ringlets. I like this image because you can see the shadow of Saturn on the rings there. So the sunlight, is above the ring plane, so it's sort of like the northern hemisphere summer, and then the shadow is cast onto the rings. Oh, there it is in false color. You can really see a lot of detail in the ring systems. So the age of the rings is a big question. How long has this been around? Why don't Jupiter, Uranus, Neptune have rings like this? Well, the answer for Jupiter, Uranus, Neptune is we think, they do have rings, but they're just very, very dim. They're made up of darker, dustier material. So Saturn, we think the rings are much, much younger and fresher, and probably a more recent impact or something broken apart that gets distributed around the planet, and there's a lot of mass. It's icy, so it's very shiny and reflective, and so it just stands out. And that is probably due to a more recent impact or breakup of a moon or something. Now, this material will not reform another moon. It can't. You're too close to the planet. And so you're inside a zone where the material will never sort of coalesce, right? So the gravity of Saturn is sort of obstructing any way that the material would want to organize or allow it to organize. So that's an effect of tides, really. So the Earth-Moon system has tides. Well, the Saturn moons also have tides. But in too close, the tidal force from Saturn, gravitational force from Saturn, is too large to allow this ring material to come together. So it stays in this beautifully thin plane for a long, long, long time. More F ring. And there you can see some clumps of material here and here. So this is debris that is breaking up, and then then it gets kind of distributed more evenly around the ring. So you heard some of those noises. So from the movie. See if this one's going to play for me. So basically, Cassini had a radio instrument on it, and Saturn is emitting radio waves, and it's tied to the planet's spin and magnetic field. So the spacecraft can monitor that, and that was because it's a gas giant. How do you determine what the rotation is? The clouds are moving at all these different speeds. So typically what you use is the magnetic field to tell you what the interior of the planet, how it's rotating. And that is the rotation of the planet. So the radio instrument does that. Also, energetic particles. So the spacecraft flew through some of these radiation belts and flew right over the northern pole and was able to directly image these aurora. So charged particles trapped in the magnetic field of Saturn and Jupiter and Earth any planet with a magnetic field has these aurora. So charged particles get trapped and then hit the upper atmosphere and basically glow. And so you've got lots of images of aurora on Saturn. So that's a Hubble Space Telescope view, and this of course is Cassini view. The atmosphere in red, and then the aurora in blue there. It's very beautiful. So here's a kind of a final count of information. This Cassini mission, as I mentioned, there's nearly 300 orbits of Saturn, 6 new moons. You can see the amount of data collected. 27 different nations participated in this mission, and 162 flybys of the moon. So it's really was quite a spectacular mission. And as I said, it identifies many people's careers for that period of time, for that length of time. Thank you very much. I apologize. I should have asked to stop me if you have any questions, but I'll do that now and just tell you that John Wallen will talk about the invisible universe and how we see it next month. So I hope you come back for that. Get your gloves on, get your hats on if you're going out. It's going to be cold, but feel free to wander on out there, and I'll be happy to hang around here and answer any questions if you have some. Thank you.
Did any pieces of Cassini land on the planet, or did it all just vaporize? And then during the entire mission back at JPL, was there a team sitting there 24/7, or the times when Cassini was just sort of flying out there on its own and nobody really monitoring it?
Yeah, so the first question is the spacecraft, yes, all burned up.
Totally vaporized.
Yeah, and once you get, well, I guess there's no way of knowing if the entire thing burned up, but once you get deep into the atmosphere, it's the pressure, it gets incredible, so it's going to just crush whatever's there anyway. But it all went into the planet. There's not any leftovers, flying around. So just like any project, as a project, you're waiting 7 years before the spacecraft reaches Saturn. So you're kind of in a maybe a straw man mode of a few people working on the mission, and then it ramps up, and you hire people and anticipate scientists, and you've got to analyze these data. And then as the mission continues, then it kind of wanes a little bit. But there's always somebody.
Somebody 24/7 kind of monitoring, but just kind of watching a screen.
Yeah, and I'm not sure with automation these days if really there's that level of somebody's always at the command, so to speak. But typically that's the way it works. Yes, and as the mission kind of winds down, then you get fewer and fewer people, and they go off and do other projects too,
But we landed a thing on Titan,
Yeah,
and it's still there.
yeah.
So we have contaminated
Yes,
Titan.
yes, that is
So-
true. Potentially we've contaminated Titan. That is true. And again, that's the risk reward for things like this. And I know that they debate this a lot. What should we do? And it's not a light decision when you do these things. But they did not want to do that with the other moons, right? So yeah, we want to get close to Titan. We want to see what it is. And there is a potential for contaminating Titan. That's right.
Did Cassini see the box on their so didn't get it out?
Yeah,
No, I don't think so.
I don't think so. Yeah.
Is the probe that's on Titan Does it move or does it just stay in place? And also, did they take any special precautions with that probe more than they did with the space shuttle itself? Just to make sure it wouldn't get to the best of our ability.
Yeah, that's a good question. I don't know. I assume so, that they took extra precaution for that. But it's all, tied to the main spacecraft, and it was just a lander. It's not moving. It just parachuted down and just flopped onto the ground essentially, and it runs out of batteries. I think it lasted about 25-30 minutes or thereabouts, and then it runs out of power. But yeah, it's just sitting there on the ground, and to the best of our ability, we try to disinfect these things so we don't. We call it forward contamination. Yeah. Sorry. Hey.
What is next, like, planned or proposed by NASA for things like Cassini?
So there's a large spacecraft going at Jupiter at the moment, the Juno mission, and I know that there is, to my knowledge, the next big one. There's a solar probe coming up very, very soon, but the planetary mission, the next big one is going to the moons of Jupiter. So they want to basically orbit some of the moons of Jupiter, many of them. And with the idea is that, can we plan a lander? Maybe on Europa. So that's going to, again, come up, the question is going to come up. All right, so we got to make sure that we don't contaminate it. And I think they really want to drill into the ice and see. I mean, it's probably hundreds of kilometers thick, but maybe they get lucky and they can drill down, I don't know, a few dozens of meters or something, and maybe they find some water or slush or something and sample it. Try to determine, is there anything there living? It's possible, but that's one of the big questions. So my understanding is the big one is and the only reason they're going to Jupiter first, it's closer, and there's plenty of moons there to study, and so that they're going to do a moon orbiter. I don't think it's a lander. That may be the next one after that. Yeah. Any others? Yeah.
You say the spacecraft burned up. Burning to me as a chemist means reaction with oxygen.
Yeah.
So certainly there's a whole lot of heat generated.
Right.
So that would melt any metals in there because it gets hot enough.
Yes.
They could then
Evaporate.
separate.
Yeah.
But the emissions of light that comes from that process may not actually be burning
Right.
per se,
Right.
but just the disintegration of it due to the high temperature.
Yeah, it's due to friction.
Yeah.
Yeah. So the spacecraft is moving extremely fast. Same as a meteor hitting the Earth's atmosphere. It's moving so fast, and there's no air in space, and then all of a sudden it finds an atmosphere, and that friction causes it to heat up and basically melt.
In our atmosphere, it actually can burn up because it comes
Yeah, right. We've got oxygen. That's right.
What is the atmosphere of Saturn?
So Saturn is 99% hydrogen and helium.
Hydrogen and
Yeah, but there's some trace amounts of methane in the outer atmosphere. Some water ice clouds, too. And I should have mentioned before, I didn't, but in those final orbits, it actually skimmed the upper atmosphere to sample it before its final descent. So that was, again, kind of a daring move to see if they could get close enough to actually be in the atmosphere of Saturn. And, but yeah, you're right. It's not a combustion reaction.
Disintegration. It didn't burn up. It disintegrated.
It melted. Yeah,
yes.
Disintegrated. That's right. Yeah. Hi.
Enceladus is spewing ice and forming Saturn. Did we get enough information from Cassini to know how long Enceladus has to live that way?
Not to my knowledge. Like, I mean, how long has it been doing this?
How much longer can it keep spewing water?
Oh, right. At the size of the moon is, I'd have to go back to one of those first slides, but it's smaller than our own moon, but not that much smaller. So roughly it's the same size of our own moon. So there's a lot of mass there. And these geysers aren't spewing that much material. I mean, it is a lot to make a ring, but it's going to last a long time if it continues to do that. But to my knowledge, I don't know if they calculated it's a million years this will last, or a billion, or what. I don't know that. Yeah. Enceladus, yeah, all these moons are a mixture of rock and ice, but most of the surface is ice, and that's where it's water ice, which is really amazing, and it's spewing a lot of that stuff out. But yes, mixture of rock and ice. That's what essentially all these tiny moons are.
In the picture of the pole, there was that one giant storm in the middle, but there was another blue thing over here. Is that another storm?
Yeah. So if I go back and find that really nice image, this one, yeah, there's lots of swirls and eddies and things because Saturn is rotating about once per 10 hours. So it's spinning pretty fast. And then you've got this, it's a ball of fluid, right? It's a gas fluid, and that's churning around, and yeah, you get all kinds of weird storms and eddies, and you can see there's lots of things. All these things are disturbances in the atmosphere there. So and the blue thing, yeah, that's another little storm system.
In terms of that hexagon, would physics normally expect a circle?
Yeah.
Okay.
Yeah. I mean, that's the weird thing. It's why is it doing this weird shape when you would think it would just be an oval or a circle or something? Yeah.
So let's say that we did land on Saturn. Did they feel the rotation of the planet?
Right. So the magnetic field is spinning around once every 10 hours, and so is the planet. I mean, you can see some features in the clouds too. And we do that with the sun. The sun is a big ball of gas. If you see a sunspot, well, that sunspot sometimes lives long enough that it'll come back around again. And that's how Galileo did it 400 years ago or so, to determine that the sun rotates once basically every 25, 30 days. So we do the same thing at Saturn. You get an approximate period if you look at the clouds, but then you're inside Jupiter's magnetic field, and you detect the presence of the magnetic field, and it's coming around once about every 10 hours. Yeah. And you can remotely do it by looking at the radio emissions that it emits. So you don't have to be in Saturn to know what its magnetic field is doing. You can do remote observations.
I was just wondering about, just concerned about contaminating planets, but I mean, the distance between Earth and Saturn, isn't there bigger mass absolute zero what would survive?
Yeah, that's...
We're thinking of some of the germs that we know on Earth, but would they even survive? I mean, we don't know. It could be methane-based life as opposed to carbon.
That's right.
I think the water means life, but it could be methane.
That's exactly right.
Anything from Earth, I would think, would be frozen and dead at one time.
Yes, but it's amazing what these. I guess it was in the early '90s when I first kind of heard it. Just grew very rapidly. A whole division within NASA in studying what's the term they call it? Life in extreme environments. And even on Earth, we see life in the strangest places. Deep oceans, there's no oxygen down there. It is a methane environment, or it's high radiation environment. And they know that there were, I don't know what you would call them, germs essentially that made it to the moon. They found them on some of the equipment later. And yeah, we'll see. But you know, think about a spore, right? It's dormant. It's frozen. Well, maybe it can unfreeze at some point. So yeah, there's potential for something to sort of survive, but it's certainly a harsh environment. That's for sure. But life as we know it seems to be quite robust. And so that's why people, scientists are so encouraged to look for it elsewhere, because we're seeing it here under some very extreme conditions. And so I don't know if you saw recently that there is a piece of cliff fell away from Mars and exposed water, ice, I should say, ice, just a few centimeters under the surface. And that's what they were thinking, that hopefully there might be some water just under the surface of Mars. And it appears that there is. And so could there be something in that frozen water? Or maybe it's liquid if you keep digging under the ground. So it's exciting. I mean, those folks who are doing biology and exobiology, I guess is the term that we call it, are the conditions and the understanding is that why not? Let's look. There's no reason not to look for life.
So have they done any purposeful experiments, like taking bacteria or something that we know from Earth to space and exposing it and seeing if it was survive?
I don't know personally, but I'm sure they're doing lots of that on the space station. But whether they're, kind of holding it out the window, so to speak, or not, I don't know how they do that. But don't open the window. But yeah, I'm sure that they're doing lots of those sort of microgravity and then high energy, low vacuum of space conditions to see what might survive, what would not. Any other pressing things? Yeah.
Is there any theories going around as to why it forms that hexagon shape on Saturn?
I don't know of them. It appears that they're baffled. To my knowledge, that we don't understand why this thing is doing this. It's very cool, isn't it? Yeah. But they do know it is a jet stream of winds, sort of like our jet stream. But why it has this shape? Yeah.
I bet it's a signal.
That's right. That's right. It's those Saturnians, those funny Saturnians. Well, thanks again for coming. And if you want to brave the cold or set up outside and stay as long as you can stand it, that's what I'm going to do. Thanks again.